Welcome, it's me, the Professor Ezouidi, breaking the barrier of classical methods. Okay, so tonight, witness the exact sample solution of 12-degree Formula equation. Let's first, let's say, share the screen with you. I will share the screen with my professors, colleagues, and mathematical researcher, and those who have smart mind, they can benefit from this lecture. Okay, so now you can see the whole lecture. Okay, I'll go look here. I shared, let's say, a link that contains PDF. Okay, I will just click on it. Live stream. Okay, solving 12-degree Formula equation. Professor Murad Sultan Ezouidi, breaking the barrier of classical methods. Tonight, witness the exact sample solution of a 12-degree Formula equation. So the limitation of classical methods. You can see that Abel's theorem general solution by radical are impossible beyond degree 4, 5, 6, and so on. Okay? Galois solution or solutions exist only in special cases. Numerical method only approximation, not exact solution. Meaning all these classical methods, including Abel and Newton and Ferrari, all of them they will give approximated truths. Okay? No full exact truths with classical methods. So our object tonight is to solve exactly the 12-degree Formula equation. You see here, the 12-degree Formula equation, this coefficient 14/02/1978 is my birthday. And in this week, 14 February 1978 means 14,021,978. And you can see all the coefficients are written here. Even this example, you can give or type into ChatGPT, they can't solve. He will use his best, and he use also system tools, but unfortunately, it can solve this equation. So, using Ezouidi theorem, you see this polynomial to the power 12. I will, let's say, uh, cancel all the coefficients 24, 264 up to 5. Okay, here. And the last coefficient has to be different to zero. Means I'm going to reduce this 12-degree from equation to second degree from equation in terms of x raised to the power 6 all raised to the power 6. Okay, key transformation. Here I will use my theorem, okay, to calculate, let's say, the s subscript k minus 1. You should use the theorem of Murad Sultan Ezouidi and set k equal 0, then set k equal 1, and then set k equal 2 up to 12. 12 minus 1 gives you 8k. Here, if you apply this theorem and make your own calculation, you will come to this one, which is expressed using special structure. Means my 12-degree from equation has to be reduced to x raised to the power 12 plus s5, x raised to the power 6 plus s11 equal 0. You can see this one like a times x squared plus b x plus c. So here, s5, my learner, professors, and colleagues is equal to 13,960,842 times 12 raised to the power 6. And the last coefficient of my new 12-degree from equation has to be equal to that, negative 879,604,006 times 12 raised to the power 12. Okay. Okay, we told that this minute 12-degree Coulomb equation that is written in terms of x raised to the power 12 minus 0 of order qx raised to the power 11 up to s11 of order r. So this problem it will be solvable. It's easy. You can do the discrete formula solving and multi-step one. Final discrete. Compute. We have S1 of 42 dash. This is according to Mr. Murat's theorem that I showed you. When putting n equal to, you will obtain this formula. You will obtain exactly like that. Okay, come here. I'll show this one to you. Okay, when k equal to, yes, when k equal to this one. When k equal to, I will obtain combination minus combination n choose 2, L0 squared plus n squared times L1. And here in our example, when putting k equal, when putting x raised to the power 6 equal y, for example, so the highest power will be 2. Okay, meaning from 12 degree comes to second degree by making by setting y equal x raised to the power 6. Means the new second degree, in fact, its highest power is 2. So I'm going to use this formula. When k equal, when n equal 2, it will be negative. 2 choose 2 is 1. Okay? It will be minus L0 squared. Means I will L0 here uh, plays the role of S5. Means minus S5 squared plus 2 squared is 4 times S11. Okay? So here, as you can see, that this is S1 of 42 dash equal negative because I use this formula. This one I try to put it to let's see this one. Okay, like that. So you can see it. Okay. Or I will do with my hands instead. Okay, down here. Okay. Okay. So we told that S1 of 42 dash equal negative S5 of order 2 raised to the power 2 plus 4 times S1 S11 of 42. Just calculation. This is the value of S1 of order 2 dash, which is equal to okay, to 100 negative 194 trillion 964 billion. Just again and again. One, two, three, three. Okay. One, two, three, four. So it will be negative 194 trillion. Then 964 billion 475. Okay, so 964 billion. Then we have 475,132,988 times 12 raised to the power 12. So this is S1 of all the two dash. When transfer this S1 of all the two dash to the right hand side, it will be negative. So this one will be positive. So the distance here is positive. Now solve for x raised to the power 6 equal negative S5 for the 2 plus negative root of negative S1 of all the two dash. This value is positive. You see? Divide by 2. So let's simplify. This x raised to the power 6 equal that means that xk equal 12. Why? Because 12, the root of S1, you see, 12 raised to the power, when you're making the root, it will be raised to the power 12. So it remains that xk equal 12 times negative 6,981,421 plus negative 1, okay, 1, 2, 3, 4 minus 4 trillion 874 billion and 1,000 and 118,000,000 783,247 raised to the power 1 over 6 exponential to k I5 divided by 6. Okay. For k, of course, ranges all belongs to the set of numbers from 0 up to up. Therefore, let's translate now the final roots. So alpha is equal in fact to, you see this one we did before I think, there is alpha here. Okay. Alpha k is equal to alpha k equal to L042 which is 4 plus xk divided by n. N is 5. So here translate the final roots, the final symbolic roots. What classical method failed in this question. Even AI can solve these 12 from vector. So let's translate it to the final root. So alpha k equal to 2 plus 6,981,451 plus negative the root of S1 according to that exponential 1 over 6 times exponential to the power 1 over 6 exponential to k plus 1 over 5 divided by 6. So let's conclude now. You see the 6 exact symbolic roots found. No approximation. Overcome Abel's and Galois limitation. With the Ezouidi theorem, the impossible becomes reality. Thank you for listening. This is the pioneers. Murad Sultan Ezouidi was with you. Thank you for listening and goodbye.